Hello, my name is Mackenzie Forte. This is for Math 117 and it's my triangle proof project. What I need to prove is triangle DEA, this triangle right here, and triangle FEC, this triangle, are congruent. And what is given to me is line AC, A to C, bisects D to F. And we can see that is true. These two lines are bisecting each other. So let's write down our given because that's how we always start our problem. Line AC bisects line DF. And our reason would be given. So the next thing we want to do is just give a bit of a more explanation to why that is true. They told us that it bisects, but let's prove it. Now, let's explain what bisect means. Bisect. Divide in two equal parts. So now we know these lines CE and EA are congruent. DE and EF are also congruent by the definition of bisector. Now let's look further into that. These are what we call intersecting lines. And what those are lines that share one point. And the point that is even given to us, E, is what they share. And that's also called a midpoint, but we don't need to write that. So now let's write what we have discovered. So, line CE is congruent to line EA, and that's definition of bisect. Now let's look at that again. Line CE, C to E, is congruent to E to A. Before we move on to the other bisecting line, let's even further explain what I've told you. So here are intersecting lines. These lines are intersecting because they come to one point, the midpoint. And right here is the vertex. I have it labeled. And why we know it's equal is because if we split a line, it always needs to equal 180. So here is one line, and let's add these together. 134 plus 46. And it's definitely 180. That's why this definitely proves our triangles are congruent to each other. Now let's move on. So we know that CE and EA are congruent. Now let's add that DE and EF are also because of definition of bisector. DE, the line, and EF are congruent. And same reason. Alright, and the last thing that we can use is the use of our vertical angle, and that is DEA, so this angle right here, and CEF, this angle. And here is that definition: vertical angles, angles opposite of each other when two lines cross. And now that we know from before that when two lines cross, it needs to be 180 on that line, that the vertex has to equal the same, and this picture demonstrates that perfectly. This is the vertex here and here, and here's the vertex right here, 134, 134, and it equals 180. Now let's write that down, but for our triangle. So angle DEA is congruent to angle FEC. And we can say definition of vertical angles, but I'm going to say vertical angles are congruent. Alright, and now we can see, which I have labeled, this line here, DE is equal to E and F, and CE and EA are equal to each other also, and DEA and FEC have a vertical angle. So we've proved that this side and this side, so let's add another line, are equal, and this line and this line are equal, and we have the angle. So I told you with audio and also visually with the added vertical angle. So we have our proof, side, angle, side. Triangle DEA is equal to triangle FEC. Side, angle, side. And that is what we wanted to solve, which is shown right here. Thank you for learning with me, and that was the end of my project. Goodbye.